In this video, we shall look at how force and potential energy are related to each other. We shall restrict ourselves to only so-called conservative forces. So in this case, the conservative force can be expressed in terms of potential energy function as follows. It is quite simply the minus position or coordinate derivative of that potential energy function, like that. And if you require vector expression, the right-hand side should have the unit vector attached along with it. Let's look at the following simple problem. The potential energy between two particles is given by that following function. Alpha is a positive constant. Find that force which one particle exerts on the other. Is the force attractive or repulsive in nature? We are given the potential energy function and you are to compute the force function. So again, going back to the expression that we have introduced at the beginning, which is that we know all we have to do to find the force is to take the derivative of the function given with respect to x, and the function is minus alpha over x to the power 6. Now you can take the alpha out, so you have this minus here, that minus will become positive, and then you take the derivative of 1 over x to the power 6, which is just minus 6 alpha over x to the power 7. The negative sign there indicates that the force is attractive in nature, and that solves the problem. Problem 2. A conservative force Fx in newtons, so F is measured in the unit of newtons and x is in the unit of meters, acts on a particle. The potential energy U associated with the particle is given by the following function, and potential energy is measured in the units of joules. What is the expression for the force, and for what values of x does the force vanishes? So since we are given the potential energy function, we can simply take the derivative of that potential energy function. So it's minus 4x e minus x over 4. So let's take all the constants out. So minus 4, bring it out. You get 4 there. Derivative of x e minus x over 4. Of course, we can use the product rule to differentiate this function. So let's differentiate the first one, x. It's going to get 1. Multiply that with the second function, minus x e to the power minus x over 4, plus first function, and then differentiate the exponential function, and that's going to give you minus 1 over 4 e minus x over 4. And that's it. Factoring out the common terms, 4 exponent raised to the power minus x over 4. So the first term is 1, the second term is minus x over 4, yields the desired conservative force function. Now we can proceed to the second part of the question. For what values of x does f equals to 0? Now that is pretty evident. When you set x equals to 4 meters, then f equals to 0 newtons. So the answer is x equals to 4 meters. Problem 3. A single conservative force acts on a 3 kg particle moving along an x-axis. The potential energy U associated with the force is shown in figure below in the form of potential energy position graph. Find the magnitude and direction of the force at x equals to 2.5. That's right there. And what is the acceleration of the particle there? We know that in order to find force, we need to take the negative derivative of that potential energy function with respect to x. So what we have here in the bracket is just slope of ux graph. The graph is given, so all you have to do is to determine the slope at a particular point. So in this case, that particular point is that point, x equals to 2.5 meters. As you can see, at x equals to 2.5, you are dealing with a straight line. So all you have to do is to compute the slope of that straight line. So the slope can be computed in the following manner. Let's determine this length over that length. So that is 3 minus 2. So that point is 3 minus 2. And that length is minus a 4 minus 1. Because this point is minus 4, that is minus 1. So minus 4 minus 1 over 3 minus 2. You get minus 3 over 1, which is minus 3, which is a negative number, and that it should be evident from the form or the shape of the graph between x equals to 2 and x equals to 3. As indicated here, this value of minus 3 is just du dx. So that would make the force minus 3 newtons, which is 3 newtons. And if you require a vector notation, you can simply write the force as 3I hat in the unit of newtons. So the magnitude of the force is 3 newtons, and the direction of the force is along the positive x-axis. Next, let's determine the acceleration. Now we know this is a single conservative force. It's the only force acting on this particle. So from Newton's second law, the acceleration is given by that force that we have computed before over the mass. So the force is 3I hat, and the mass is also 3 kg. So that means you get 1 I hat in the unit of meter per second squared. And that solves the problem. Problem 4. An object is moving in xy plane. So this is a two-dimensional motion, and the object is acted upon by a conservative force described by the following potential energy function. So that is the potential energy function, and as you can see, it is function of both x and y. Find the expression for the force vector, and what is the magnitude and direction of the force at that point. So generally, the force is a function of both x and y. Now, force is a vector, and we have to generalize that equation that we have seen before, namely this equation that relates conservative force to a potential energy function. Of course, you have two variables, so the derivative will become partial derivative. So the first derivative is partial derivative of u with respect to x, I hat, followed by derivative with respect to y, j hat. So this form is generalization of this form to two dimensions. So let's compute the first derivative, minus partial derivative of u with respect to x. So you have one x term there, another x term there. So the first term will give you simply 4x. The second term can be differentiated by treating y as constant. So that's going to be plus 3y. So that's your I hat. Now the second derivative, partial derivative of u with respect to y. So you have the first y term and the second y term. So the first y term upon differentiation will give you 4y. The second term is differentiated by assuming x is constant, and that's going to give you 3x j hat. So there we have it. That is your force function. Minus 4x plus 3y I hat minus 4y plus 3x j hat. And this is the expression for the force vector that we are looking for. So what is the magnitude and direction of this force vector at that particular point? So all we have to do is to substitute the value of x and y, x equals to 1 and y equals to 2 in the above expression. So when x equals to 1 and y equals to 2, so you have 4 plus 6, so that's going to be 10I hat. So minus 10 is your x component. Now let's do the y component. Y is 2, so that's going to be 8. X is 1, so that's going to be 3. So 8 plus 3, so that's 11j hat. So the y component is minus 11. We note the unit is newtons. So we can easily compute the magnitude. So the magnitude is minus 10 squared plus minus 11 squared square root. It's just a magnitude of a vector. And you're going to get 14.9 newtons. Now let's do the direction. You see that the x component is minus 10, y component is minus 11. So that is 10 and this is 11. So all you have to do is to compute this angle alpha. So alpha is arctangent 11 over 10, which will give you 47.7 degrees. So this is the plus x-axis and this is the minus x-axis. So we say the direction of the force at point 1, 2 is 47.7 degrees below negative x-axis. And that solves the problem. Thank you for watching.